So here is our solar system that we are going to create in Maya and Houdini. So here we have some of the planets. We'll just stop playing. Alright, let's create a new file. A new scene and create a sphere. Let's go to channel box. Here is our channel box. And click on P-Sphere 1. And let's rename it to Sun. Let's launch Houdini. We might increase our subdivisions axis, and make it 50. So our sun will be revolving around y-axis. Y-axis here. It's the green line, our y-axis. We just go to Windows and Animation Editors and Expression Editor. Okay. So here we have our sun. It's a polysphere. So we need rotation around y-axis. So here we have our attributes. So sun rotate y. So just let's copy and paste it into the expression field here. So our sun rotate y will be equal to time. So it is revolving, but the speed is very slow. So let's multiply our time by 5. So our time parameter by 5, or maybe even 50. So let's make it 50. So our sun is rotating now. Let's go to Houdini. And here we just create sphere also. So let's make it 0, 0, 0. So double click on our sphere node object. Just go inside. We might just click enter, just press enter. So here we have rows and columns. It's similar to Maya subdivisions height, subdivision axis and subdivisions height. So here we have our sun. So we need our sun to rotate as well. So we might rotate later, or we might just rotate now. Let's make it rotating in the y-axis. Just type upper sun time and frame. So just frame should be capitalized. So our sun is rotating here. So here we have global animation options. It's in the lower left corner of the interface of Houdini here. Just click and make it our timeline 4080 and press apply. So our sun will be rotating here. So we might rename it to sun, double click on the node and rename it to sun. So now when we have our sun revolving, rotating in Maya and Houdini, so it's rotating. We have add frame expression in the Y field here for the rotation. So let's press tab and start typing geometry. Select geometry node. Then go inside that node. First rename it to Earth. Go inside that node by just pressing enter or clicking twice. So now when we are inside, press tab and start typing sphere polygons to create a polygon sphere. Okay, let's increase rows to 50 and columns to 50 as well to make more divisions. Now let's create the Earth planet in Maya. So press sphere on the shelf, on the polygon shelf, or alternatively we can go to create polygon primitive sphere. So we create a sphere. Let's just press stop. Now we have the sun, P-sphere 1. You know, we need to scale our sun to make it bigger. Let's just press 5 frame mode here in Maya so that we can see our Earth inside the sun. P-sphere 1. Now go to the channel box in the upper right corner. In the shapes we press Polysphere 2 and let's rename it to Earth. Our Earth, the Earth planet. When we go to Windows animation editors, expression editor, we will make our Earth orbiting, revolving around the sun. So press Earth and press translate X, press translate X. Copy this from the select object and attribute field and paste it into the expression field. So we have the first part of our expression Earth dot translate X equals sign. In the parentheses we will type frame. and end with the semicolon. And if it's time from the capitalized letter, it just generates a mistake. So we need to make it from the small letter, not capitalized. And now we have our expression. The Earth is moving along x-axis. Let's copy this expression and paste below and change x to y and change the sine function to the cosine function. Let's press edit to create our expression, to modify our expression. And now our Earth is rotating, revolving. But we need to change y to z axis so that we'll have our orbiting in xz plane, and our Earth is revolving around the sun. So if it's just like y-axis in the center. Next we multiply our expression by 5, for example, to make the diameter of our orbiting bigger, to push it further away from the sun. Let's press stop and press smooth shade all mode. And when we press play, we'll see our Earth, that our Earth is rotating, revolving on its orbit around the sun. Let's press stop and go to Houdini, okay? Here we also write a similar expression for the Earth. For sphere 1. So let's press tab and start typing attribute wrangle node, and then connect our attribute wrangle node to the sphere node. And now we create our expression. So we will write at p dot x or z or y, doesn't really matter, plus u equal to sine function, and then in the parentheses we write at time and end with the semicolon, and press create spare parameters for each unique call of channels. So we create our first expression, the first part of our expression. So now our Earth is moving along x-axis. We just copy this expression, okay? And let's write at p dot z plus equals cosine, and in the parentheses we write at frame, and we write at time and end with the semicolon. Then press create spare parameters. Now we have the Earth orbiting the sun. Likewise in Maya, we'll make our Earth further away from the sun. So we will multiply our expression by 5 as well. Multiply by 5 our sine time expression, and now the cosine time expression as well. So now we have the Earth orbiting around. So now we have the Earth orbiting the Sun. Basically, this expression means that the points of our object are moving along x-axis during all frames according to the sine function, and along z-axis according to the cosine function on the timeline, and we have revolving or orbiting motion. Let's go to Maya. In Maya, we select filter. In select filter, we'll choose by expression name, so we will see our expression, and we rename our expression to, for example, Earth. And expression 1 will rename to Sun. In Houdini, we might rename attribute wrangle 1 to Earth rotation. Earth rotation. When you go up to the object mode, to the object's context, we see our spheres, like see the expression at frame. When we select Sun and make uniform scale bigger, actually our Sun is 109 times bigger than the Earth. But we will not stick to the original scale, because otherwise the Sun will go so big and our Earth will be so small, and it won't be very distinctive. So it will make the great difference in size. It will make our picture indistinctive. So when we select the Earth, see we don't need to select the Earth and make it 100. We will make our Sun 100, okay? So our Earth is bigger. Our Earth is bigger. So let's make our Sun 100. Let's make our Sun uniform scale 100. And then we will see that it is so big and our Earth is so small, so we won't really see our Earth. Just we cannot make anything out. So let's make uniform scale 2, or maybe a little bit bigger. Let's make it 3, for example. If we take our planet, the Earth planet, as one, then we will compare how many times other planets are smaller or bigger than our Earth planet. The first planet, well, of course, Sun is 109 times bigger than our our planet, and it's 1.4 million kilometers in diameter. Then the next planet is Mercury. Mercury is 4,879 kilometers in diameter, so it's 2.6 times smaller than our planet. Okay, then the next planet is Venus, and here is our planet, the Earth planet. So if we press F, we will see our planet. Okay, so it's 12,756 kilometers in diameter. Then the next planet is Venus, and Venus is 12,104 kilometers in diameter. It's almost the same and very similar to our planet. And the next planet is Mars. Mars is 6,779 kilometers in diameter, and it's 2 times smaller, approximately 2 times smaller. Then goes Jupiter. Jupiter is 142,984 kilometers in diameter, so it's 11.2 times larger than our planet. Then goes Saturn. Saturn is similar to Jupiter, and Saturn is 120,500 kilometers in diameter. And the next we have Neptune. Okay, so the next we have Uranus. We have Uranus. Uranus is 51,118 kilometers diameter. It's 4 times larger than our own planet, than the Earth planet. And then goes Neptune, and Neptune is 49,528 kilometers in diameter, and it's 3.8, approximately 3.8 times larger. Then we have Pluto. Pluto is just a so-called dwarf planet. It's 2,372. Here we have our Pluto, small planet. Very small. It's called another name for this planet is like a dwarf planet. So it's just very small. It's 5.6 times smaller than our planet. So here is our planet. Okay, in natural size. Okay, in natural size. So, but regarding distances between the planets, it just well, the distance is very. For example, if you take if you take the distance from Earth to Sun, it's approximately 149 million kilometers. So actually it's just it will be very difficult for us to show this distance here, because for example, it's like our grid, but it's hidden behind the sun, you see. So if you take, for example, if you go to four panels view, we will see. So it just for example, if you take Earth, for example, if you take Earth, it just if you take, so one square, it's just approximately 6,000 kilometers. So imagine if it's 149 million kilometers the distance. So we should move our planet way beyond, like so many times. So then we will have our planet so small, so we won't be able to see them and to see their representation, and we will not have any idea how it looks. Okay, so the proportion. So we just we will not stick to actual distances between our planets. All right, so let's just go back. Okay, so here is our solar system. So all right, let's select our sun and make our sun scale maybe 70. And our Earth, let's just select translate X, translate Z, and go to edit expressions and change it to maybe 20, and press edit to create expression, to modify our expression. Let's go to wireframe and shade it. Let's just select wireframe. All right, I think 20 is still not enough. So let's make 50. And press edit. And still not enough. Maybe 200. Edit. Okay. Let's just select our Earth. And make its scale maybe 9. So 9 will be okay. Looks fine. Okay. Let's make the same for Houdini. So here is our sun and our earth. So we just select the sun first and make it scale 70. Just zoom out. And now select the earth and make the uniform scale 9. Okay, let's play. And again, we can make our earth further away from the sun. So we'll go inside the earth node. Just click twice or just press enter. And in our expression we change 8 and make it 20, for example. Let's make it 20, for example. Let's play. Zoom out. I think 20 is okay. If you make it like 200, like in Maya, it might be too much. So just zoom out. And so it's too much, yes. For Houdini it's too much, so let's go back to 20. Now let's add our moon here. We just click on the sphere icon on the shelf here. Okay. And we can't see our sphere because it's in the origin. If we enable our grid display, okay, let's just press 4. Okay, our grid is very small and our sphere is very small. We just move our sphere here and make its scale a little bit bigger. Okay, when we play, we see that our moon is not connected to the earth, so it's not rotating. To connect it to the earth, we need to select our earth. Let's rename our sphere to moon and select our earth. Shift select our earth and go to edit and choose parent. Now we can see that our moon is moving together with the earth. It's rotating with the earth, but it's not rotating around the earth axis, so we in the second part we will deal with that. Okay, in Houdini, we have our earth, okay, and the sun. Okay, in Houdini, when we create the moon and create the sphere, we just press tab and start typing geometry and place geometry node. Go inside that node, press tab and start typing sphere and add the sphere node here. And again, it's not visible because we're just inside the node, because we're inside the sun. So we go to the wireframe display. We need to select our moon here. Let's rename Geo1 to moon. Okay, and select our moon, and then select the translate tool and make its scale bigger, to make it bigger to see our moon. And go to flat shaded again displaying. We can see that the moon is not parented to the object. To parent the object to another object in Houdini, we need to connect our nodes. So we connect our moon to the Earth, or vice versa, we connect our moon to the Earth. It disappears. It disappears, and it's not moving because it's controlled by an expression. So if it's controlled by an expression, we cannot preserve the rotation and the translation. So even though when we select our node and then select our moon and keep position when parenting, if we check this option, it's still not working. So it's just, for example, let's hide our Earth and select this connection and delete this connection by pressing delete key on the keyboard and hide our sun. So if we select, so we will create another sphere and start typing geometry and go inside that node and press tab and start typing sphere. So now we have our sphere, but it's very small. And let's make its uniform scale a little bit bigger. Okay. It will be our Earth, for example. Let's rename that node and rename it to Earth. And that will be moon. Parenting will work if we will make our Earth rotating around y-axis. Let's just make the expression frame, upper sun and frame. If we go to flat shaded mode and zoom in, we see that our sphere is rotating. So what we can do, we can change the pivot translate here. So we change the pivot translate, for example, here, like this, and like this. We see that our Earth is rotating, is orbiting around the sun. Imaginary sun, around our imaginary sun. Let's say it will be our Earth, and then we parent our moon to Earth, and now it's working. So it's like in Maya. So in the second part we will deal with this problem, how to preserve rotating while having expression of our moon and rotating around the Earth axis, because we didn't use the expression here. Okay.